Hello everyone, I am Vipin Pandey and I am back with my new lecture series for this NIELIT Exam Scientist A and B post. Last time we have discussed Computer Science and Engineering 2016 paper. Today we are going to 2017 paper, that paper which is held in July month itself. If we discuss what we find, that 2016 paper is of level of Scientist A, that's Scientific Assistant post, while 2017 paper is more or less of a numerical more type question. So it will be the one which we can say that it is of level B, and it's the exam was a little bit on tougher side, and most of the questions were from data structure, graph theory, and operating system, and many questions in terms of programming were lifted directly from pointers and see. Although it was a simple concepts, we will see today, but most you have to be a little bit thorough enough to attempt those questions. So as I already told that we are having around 382 posts or 340 for scientific assistant and 42 for scientist level B. So if you ask my opinion, the type of paper that is being held in 2017 is more apt for scientist level B, and 2016 paper is more apt for scientific assistant. Although if NIELIT people are lazy, then they can ask same paper for scientific assistant and scientist B with different cutoff. So for scientist B post, there is not much problem. You have to be at the higher side of your study. While scientific assistant, you need to be on your toes for both kind of paper. तो ठीक है, हम देखते हैं कि what पेपर पैटर्न इज़ ऑफ 2017, एंड मुझे लगता है कि ऐसा कुछ नहीं है, कोशिश करने पे आसानी से सारे सिलेबस को कवर किया जा सकता है. सो दिस इज़ कंपैरिजन ऑफ क्वेश्चंस आस्क्ड इन 2016 एंड 17 और किस पर्टिकुलर पार्ट से आए थे. सो वी हैव आई हैव कंपेयर्ड, एंड द रेड वंस आर द वन which was a major improvement on the number of questions that has been asked. See, operating system is 17 से 13 jump हो गया, algorithm से 4 to 17, software engineering 4 to 6. Okay, and इंजीनियरिंग मैथ्स बिल्कुल ही हटा दिया इन्होंने. डाटा स्ट्रक्चर 3 to 5, ग्राफ थ्योरी में एक क्वेश्चन आया था 2016 में, 2017 में 7 क्वेश्चन है. सो इफ़ यू टेक केयर ऑफ ग्राफ थ्योरी, डाटा स्ट्रक्चर 5, 7, 12, software engineering 6, 18, और algorithm 7, 25, and operating system 30. So 38 questions you are getting from this 5 subjects itself. So I can say it will be good bet to go in thorough in those subjects and be prepared in that. Okay, so it's now time to take a detailed overview of the paper that is being asked in 2017. So this is a section B, Computer Science Engineering 2017 paper. Section A is more or less the things I have discussed in the first video series of this whole process. ठीक है. So first one is choose the most appropriate option. What does the following function do in the linked list? ठीक है. तो if you don't know linked list and on declaration, तो इसमें पूछा भी नहीं है कि whether declaration default or not. It is simply saying that function 1 is head of next and printing head of data till head is equal to null. ठीक है. तो आप ये देख रहे हैं फंक्शन में हेड नेक्स्ट करता रहेगा जब तक हेड नल ना हो जाए. सो इट्स अ काइंड ऑफ रिकर्सन, और जो हेड नेक्स्ट करते हुए अल्टीमेटली हेड नेक्स्ट में आते हुए हम फंक्शन का जो ये लास्ट वाला है व्हेन इट बिकम्स नल, यहाँ से प्रिंटिंग चालू होगी. ठीक है. सो इट्स अ रिकर्सन एंड इट इज प्रिंटिंग इन reverse format. So prints all nodes of linked list in the reverse order. Okay, and next, which of the following graph is true for an undirected graph? So statements. So number of odd degrees vertices is even. Obviously source or destination is an odd degree vertices, and there are two, so it is even. Sum of degrees of all vertices is even. That's a primitive property. So both P and Q is the option. Next, consider the following function that takes the doubly linked list as a parameter. ठीक है. Same kind of thing. If we don't know, तो यहाँ पे क्या किया है, टेम्प में करंट प्रीवियस का वैल्यू स्टोर किया, करंट प्री में करंट नेक्स्ट का, करंट नेक्स्ट में टेम्प का, करंट को करंट प्री में करंट. सो व्हाट वी आर सीइंग इट्स काइंड ऑफ स्वैपिंग यूजिंग टेम्प. ठीक है. और फिर करंट को करंट प्री से दोबारा इनिशियलाइज कर दिया टिल टेम्प इज नॉट इक्वल टू नल. सो अगेन वी आर हैविंग दिस थिंग 1 2 3 4 5 6. तो 1 से 2 गया, ठीक है, 2 से 1 कर दिया. सिमिलरली तो करते हुए हम वी आर सीइंग दैट इट विल बी 6 5 4 3 2 1. ओके, so option is C. Next is this one, let A be a square matrix of n cross n. Consider the following program. Expected output I into 1 to n, j is equal to 1 to n. टेम में a i j प्लस में प्लस c कर दिया है. फिर a i j में a j i मतलब आपका ट्रांसपोज करके जो वैल्यूज़ हैं उनको a i j में स्टोर कर लिया है. देन a j i में टेम में माइनस c कर दिया. सो ऑब्वियसली व्हाट यू आर सीइंग, इफ इट इज़ द अपर मैट्रिक्स को लोअर मैट्रिक्स में अपर मैट्रिक्स करके फिर फाइनली उसमें प्लस सी से माइनस सी कर दिया. तो अल्टीमेटली व्हाट वी आर सेइंग इज व्हाट वी आर गेटिंग इज द सेम मैट्रिक्स इटसेल्फ. So the matrix A is itself. So option is A, and we can validate the same thing by taking one matrix as an example, और same चीज़ same process आप करके देख सकते हैं. It will be coming the same matrix itself. Okay. Next is this, following is C like pseudo code. स्टैक एक्स एस में वैल्यू डाल रहे हैं टिल, और फिर उसका n% मॉड्यूलर डिवीज़न कर रहे हैं. फिर n इक्वल टू n बाई 2. तो ये वैल्यू पुश करते जा रहे हैं. तो वॉट एवर द रिमाइंडर इज आइदर 0 और 1, बिकॉज रिमाइंडर कैन बी 0 1 इन टर्म्स ऑफ डिवाइडिंग इट बाई 2. एंड देन पुश कर रहे हैं. सो इट्स अ प्रॉपर्टी ऑफ रिकर्शन इटसेल्फ. एंड व्हेन यू आर पॉपिंग इट आउट तो अल्टीमेटली एल एस बी पहले बाहर निकल के आएगी. सो वी आर प्रिंटिंग binary number representation of n. That's B option is the correct option. Next, assume that the operation plus minus into are left associative, and this power sign is the right associative. So the order of precedence from highest to lowest is so we can see. अच्छा, लास्ट जो क्वेश्चन में मैंने जैसे ये टेम्प वाला लिया है, तो यू शुड बी मोर स्टडीड कि पैलिंड्रोम का कैसे सॉल्व करते हैं. सिमिलरली नो वेरिएबल स्वैप कैसे करते हैं, बिकॉज दोज आर द क्वेश्चंस ऑनलाइन ऑन विच दे कैन आस्क क्वेश्चंस. ओके, ठीक है. अभी ये है a प्लस बी और डी ई एफ, इनका फर्स्ट प्रेसिडेंस है दिस पावर सिंबल का. सो इट विल कम डी ई एफ के बाद आ गया, देन डी ई एफ एक साथ होकर के राइट एसोसिएटिव में चला गया. ठीक है. नेक्स्ट प्रेसिडेंस है मल्टीप्लिकेशन का, तो बी सी के बाद आ गया, पोस्ट फिक्स है ना. एंड देन ए प्लस, तो ए बाद में आ गया ए बी सी प्लस, और लास्ट में से माइनस बचा, सो इट इज़ कमिंग लास्ट में. सो दिस इज़ द ऑप्शन, दैट इज़ ऑप्शन ए. ओके. A balance factor in AVL tree is used to check. It is used for checking what rotation to make. Okay, to make the tree balance again. एक प्रायोरिटी क्यू इम्प्लीमेंट करना है मैक्सी फॉर्म में, और 5 एलिमेंट्स हैं जिनका लेवल ऑर्डर ट्रावर्सल 10 8 5 3 2 है. 1 7 न्यू एलिमेंट एंटर किया है. सो व्हाट विल बी द लेवल ऑर्डर ट्रावर्सल? सो द लेवल ऑर्डर ट्रावर्सल ऑफ द हीव आफ्टर द इंसर्शन ऑफ द एलिमेंट्स. So for solving it, level order traversal is 10 8 5 3 2 है. So you just arrange 10, उसके अंदर 8 5 3 and 2. Now inserting 1 and 7, so 5 के नीचे 1 and 7 आ गया. And once it is done, so it's a max heap, so the parent should be having the maximum weight. So 7 ऊपर चला जाएगा, 5 नीचे आ जाएगा. And now again level order traversal, so 10 8 7 3 2 1 5. So that's 10 8 7 3 2 1 5, option A. The worst case running time complexity of insertion, merge and quick sort. Okay, so that is here I am having that table. Insertion sort का worst case O n square है, merge sort O n log n है, और quick sort O n square है, depends upon the pivot. Okay, so this is an important table, you should recall. Oh, now it's they can ask any other sorts. So it's O n square, O n log n, and O n square. Okay, next is NQ and DQ operations in a queue. It's like a stack that is having a push and pop. In queue there is a FIFO where you insert element at the rear end and delete from the front. So inserting at the rear is called through NQ, that is carried out in O1 time, and DQ, that is deleting end of the front, that is also carried out in O1 time. So both operations can be performed in O1 time itself. Next is in this graph L we have to find a bridge. Okay, so what is a bridge? Bridge is an edge on removing which the undirected connected graph becomes disconnected, or it is having more than two disjoint sets. So we will see which edge removing them make this graph disconnected. No bridge edge is the first option. D hatan is E becomes separate from this whole thing, so it becomes disconnected. CD hatan is it is still connected to CFDE, this whole thing. CDCF में CDCF दोनों हटा दिया तो it becomes disconnected things, and it also becomes disconnected thing. So both options are correct, but I am choosing DE right now. Okay. Next is Euler circuit. Okay, so we need to know Euler circuit, Euler path, Hamiltonian circuit, Hamiltonian path. Okay, circuit क्या है कि when you start from the point, you have to come back to the same point, then it becomes a circuit. And if you do this all the underlying process, but you don't come to the starting point, it becomes a path. Okay, Euler circuit means you have to, in a connected graph, you have to go through all the edges at least one and come back to the originating thing. You have to go Euler for E है ना, so Euler, so it can be Euler for edge, and Hamiltonian is for V. Okay, so you have to traverse each vertices without traversing more than once, and you have to come back to the original path, that is Hamiltonian circuit. Okay, so the following graph has no Euler circuit because since it is disconnected, हमें एक edge चाहिए to go through all the edges of this one, so it is not connected. Next is Hamiltonian circuit, so हमें each vertices में जाना, we have to go to each vertices, that is A to E, E to F, F to D, D to C, C to B, and again A. So E, F, D, C, B. Okay, if G is an undirected graph on n vertices with E edges, then it's obviously we can put 2 points A and B, so we are having one edge for two vertices, so E is less than equal to 2n. If it is not all n connected graphs, it can be less than 2E should be is equal to or less than equal to 2n. Okay, next is what is a planar graph. Plane graph means there shouldn't be no intersection. So all after this thing, a graph drawn in a plane in such a way that any pair of edges meet only at their end vertices. Okay, it is not intersecting, that is K4 K5 type of graph, which is having a unique representation without an intersection. Okay, so next is we need to have an propositions where it's tautology, and not we have to check. Tautology means all true. Okay, and so we have to see for if condition, what is if A then B. So if it is A, then all the cases are true except T to F, it becomes F. Okay, so similarly for bidirectional, biconditional, it should be that if all the both A and B are true and or false, then it becomes true. Either if one is true and one is false, it becomes false. So that is exactly opposite to the XOR circuit. It is equivalent to XOR for the bidirectional. So this is all like disjunction is OR, conjunction is AND. So this all thing has to be taken care of. Okay. Next is digital multiplexer is basically a combination logical circuit. So digital multiplexer we first initially and then we it is being OR, so it becomes and OR type of combination logical circuit. A XOR B है equal to C. तो XOR की property है that if element A is XOR with the result, then it will give to the element B, and if element B is XOR with the element C, it gives element A. Both are available here. Okay, so it's an A and B both. X plus Y ये element ये gate क्या है, we have to find it out in this question, and X plus Y डाला है, and what will be the value for this gate. So we need X dash plus Y dash. OR gets, we will get X plus Y, and gets X dot Y, and AND gets X bar dot Y bar or plus Y bar. Yeah, so we will getting through NAND. So that's a C. Now we have to find a redundant gate in this particular network. So we can pass through an value of WZXY, and you pass through whole network and find out what the value, and then skip one gate at each time and find it out, and try to find it out which particular gate skipping will give the same output. So that becomes the redundant gate. So in case it's gate number 2, what will be the, this is given below is 2 NAND gates to which of the following interval gates is equivalent. This is an AND gate, with an OR, and it's passing through an AND gate which is short, so it's behaving as a NOT gate. So NAND, again we are passing through NOT, so this NOT and NOT get cancelled, it becomes an AND gate. Okay, now what is the average access time for drum rotating at 4000 revolution per minute? ठीक है, 4000 revolution in 1 minute, that is 60 seconds. ठीक है, तो 1 second में हो गया एक्सेस टाइम, हो गया 60/4000. Okay, but since we need average access time to 1 by 2, it becomes 60/8000, so it will be 6 by 8, so 7.5 something, 0.75. Okay, and this 3 calls up, so 7.5 milliseconds. Now comparing the time taken for a single instruction on a pipeline CPU with time t2 taken on non-pipeline but identical CPU, we can say that, see, it's a single instruction. So single instruction go, so if you pass through a pipeline, it is going to take more time than a singly rightly passing through a non-pipeline one, because there is no need for it's a single instruction one. So obviously it will be t1 greater than t2. So next is how many wires are threaded through a course in a coincident current core memory. Coincident current core memory is a random access memory which is used in 1955 to 75 eras, and वहाँ पे you have two wire thread which is connected to the random access memory for reading and writing operations separately. So the answer is 2 here. This is a tough question, and I also read it and then I'm telling you. So it can be carried out through if someone has read those server side storage subjects. Okay, so which access method is used for obtaining a record from cassette tape? Cassette tape, we have seen that we use pencil for forwarding sometimes, and for backward playing some backward song. So it's in a sequential fashion. So the answer is the B one. Okay, B, sequential. The process of converting the analog sample into discrete form. Okay, we are converting analog into discrete form. Okay, so that is what it is called. So analogs, we will taking some samples and then we have to convert into discrete one. So the process known as sampling. Next is, which memory is difficult to interface with the processor? Obviously the answer will be dependent on any memory which is refreshing at a very fast rate, and it becomes difficult to synchronize with the processor's cycle and with that refreshing rate. So that's with the dynamic memory, so it becomes difficult to interface with the dynamic memory. Okay, next is, for a memory cycle, the cycle time is, obviously it depends upon the access time, but apart from it there is some time delay on if the IO is busy and all, and some latency and all. So obviously it will, in ideal it can be equal to access time, but obviously it is not, so it is little bit longer than the access time. Okay, the option B. In comparison with static RAM memory, the dynamic RAM memory has, so it's a peculiar feature, so it has to be studied and read well. Or dynamic memory is, RAM memory is refreshing kind of, where things has to be dynamically upgraded. So it's having a higher bit density, while at the same time the low power consumption, because constantly going on and off. Okay, so it's saving some lower some power at that time. Next is, if each address space represents 1 byte of a storage space, how many address lines are needed to access the RAM chips arranged in a 4x6 array, where each chip is for 8x B, 4 bits. Okay, see, total chips are arranged in a 4x6 array, मतलब we are having 24 arrays. So 24 array को access करने के लिए we need bits. So 2 की power 4 मतलब 4 bits is 16, and 2 की power 5 is 32. So 24 is in between, so we have to need 5 bits for accessing each box of this 4x6 array. अच्छा, each chip is 8 cross 6 cross 4 bits, और हमारे पास we are having 1 byte of storage space. ठीक है, तो 1 byte of storage space को हम bit में convert कर लेते हैं, that is 8 bit. So total we are having 8 cross 4 divided by 8, so that is 8K क्रॉस 4 हम इसको यहाँ से भी देख सकते हैं. ओके, ठीक है. So 8K क्रॉस 4 मीन्स 8K हो गया 2 की पावर 13, 4 2 की पावर 2, so 2 की पावर 13 plus 2 2 की पावर 15. This address is 1 byte, तो 8 bit, तो 2 की पावर 3 divided हो गया तो 2 की पावर 12. So this 12, this power is the address lines is needed for this arrangement, or that 4 bit extra is needed for that 5 lines for accessing that 4 plus 6 array individually. So total 17 lines. Okay, so I have covered half of the questions right now, and the length of the video is going far away from my expectation, so I will be coming back with a second part of this. And this kind of paper you are seeing, it's a little bit tedious one, and I believe that this kind of paper will be the apt one for the scientist be. So people, be on your toes for studying all those typical things, and be broad enough for accessing all those stuff. Okay, and please feel free to, if you have any doubts, and I will try to come make the next part as early as possible. Thank you for your responses, and lastly, thanks and keep working.